Yeah, Tarun, you can start.
Yes. So basically first question में हमारे पास जो question था.
Tarun, just communicate in English because in interviews you will have to communicate in English.
Okay sir. Sorry sir. So basically the first question was we have given to we have to find out we have given a positive integers array and we have to choose who will win Bob or Alice, and the question be like that: Alice and Bob are playing, and if that single digit sum is greater or the double digit sum is greater, then we can simply find that by calculating single digit sum and double digit sum separately. And if it is equal, then Bob will win, else Alice will win.
The algorithm is clear, everyone. Just give a like or something, yes or no. Tarun,
Yes, it's clear.
Mehul. Okay, great. So let's go to the second problem. Anyone did the second problem? Deeptiman, you did second, right?
Yeah, yeah.
So the major observation that you have to make in the second problem is that uh, what is a special number? Okay. So Dityan, you can go ahead with this problem.
Yeah, one second.
So the key observation here is that a special number is a perfect square of a prime number. Okay.
Is my screen visible?
Yes.
Okay, one second. So yeah, basically in this question we are given L and R. So basically it's the range, and we have to find the numbers which are not special. So special numbers, they have said, like any number who has only two proper divisors. So we can, like, for special numbers we can easily say ki uh, the squares of the prime numbers are special numbers, right? Because like, one second.
Because any other number will have more than two
Yeah,
factors,
yeah, yeah,
two proper
yeah,
factors. Okay.
yeah. So yeah, it's this part is clear, right?
Everyone, this part clear that a special number will be per, will be the square of a prime number. This everyone has understood.
Yeah.
Okay.
Okay, so after that, like, what we can do, since L and R, they are in the range of 10 to the power 9. So in the worst case, it can be 10 to the power 9. And like, so what I actually did was like 10 to the power 9. So we can like easily say ki the square of the number, like maximum 10 to the power 4 will be there. Like we will be checking the prime numbers which are till 10 to the power 5. Okay, and so we'll be finding each prime number, and we'll see like how many prime numbers are there in that particular range. And we'll be using the sieve algorithm. And here I have done this. Basically, this is an f function. This function basically calculates, like, there's a boolean prime array which actually will store the like the prime numbers from like till like 10 to the power, I have taken 10 to the power 6. We can also take 10 to the power 5 also. And after that, like, we'll be like taking each number, and we'll be seeing whether like it is in range or not. And if it is in range, that we'll be just incrementing the count. And after that, we'll be taking r minus l plus 1 will be the total number of numbers in that range, minus the count. Count is basically the prime numbers, the square of the prime numbers, which will be in that range. So we'll be getting this answer like this.
Everyone got the logic? Anyone having doubts? If you have doubts, just pick it up. Yeah, Gaurav, tell.
Nothing. I was just understanding the implementation. The logic was that we
Implementation
have
is
to.
very simple. First, you use sieve to find out the prime numbers from 1 to 10 to the power 5, and then check like how many of the those prime numbers actually have their perfect squares between L to R.
Yeah, the logic was that only. We have to just find the
Cool,
squares of primes in
cool.
the range.
So let's move to the third. Let me present the screen. Diptiman, you can stop presenting the screen.
Anis, can you optimize further? We can
We
take
can
the
optimize
square
further.
root of the. No. I'm not saying the optimization. Like every time we don't no need to like calculate all the prime numbers here. Like we can directly take the square root of the n. Then we will find the all the prime numbers in the between the one and square root of it. Is that like looks good?
Yeah, that also looks good. Yeah. But like I think this implementation will be much more easier. What Diptiman told.
Yeah.
Okay. But your solution also works that you find the prime numbers from 1 to square root of L, and you also find the prime numbers from 1 to square root of R, and then subtract,
Yeah.
right?
Yeah.
Yeah, that
Right.
will also work, but you are running sieve two times, right? In that case, here you only have to run sieve one time. So both of them works, but Diptiman's one is much more easier to implement.
Okay. Okay.
Cool. I think let's begin. Share the screen. So let's talk about the third problem. So the third problem says that given a string, you have to find the number of dominant substrings. Okay. So a dominant substring is a very simple term. So if in the substring, if you have uh, more than the so let's say if you have x ones and if you have y zeros, so they are saying that if x is greater than square of y, then it's a dominant string. Okay. So here what's the most important observation? How much can y go up to? For a substring to be dominant, what's the maximum threshold of y? Anyone?
Root n.
Yeah.
Square root of number of one.
Yeah, square root. So the number of ones can go up to n, right? Which is the length of the string. So y can go up to square root of n. Okay. So in a substring to be, so for a substring to be dominant, okay, listen this very carefully. For a substring to be dominant, you can have at most square root of n zeros in it. The moment we have more than square root of n, we will stop the operation and tell that this string can't be dominant. Let's go to the next substring. Okay. Is this clear? Yes or no? अरे कुछ तो बोल दो.
Yes.
Okay. So
Yeah,
now,
got it.
so now basically we will. It's kind of a brute force where we will try to iterate over every substring, and just we will have a case that if the substring has more than square root of n zeros, we will stop the iteration. Okay. So the time complexity will be n into root of n. Okay. So if you see the constraint is 10 to the power 4, like it's 10 to the power 4. So n root n will be roughly 10 to the power 6, so it will work. Okay. So now let's see how can we implement this. So basically we will fix the starting index. Okay. So for example, we will start from this index and find out that how many substrings are there starting from this index and are dominant. Okay, and before that we will make one more calculation on the positions of 0. Okay, so we will have the index 0, we will have the index 1 2 3 4, and we will have the index 6 in it, so it stores the position of zeros in it. Okay, next we will start from an index I. Let's say we are starting from index I, and we will iterate over all the position of zeros which are greater than I. Okay, so let's say we are taking this calculation of the first index, so I is 1 here. So we will take two indexes which are 4 and 6. So 4 and 6 are greater than 1. So we will see that how many dominant strings we will find between 1 and 4. Okay, समझ में आ रहा है what I'm trying to speak?
Can you repeat again?
So basically we will store the position of zeros in an array. Okay, and then we will check for every starting index, or like we will check for every index how many substrings can be there such that the substring starts from I and ends at any other index. Okay, so one more thing you need to understand while solving substring problems. Basically while solving substring problems, either you need to fix the starting index or you need to fix the ending index. Okay, because a substring can be uniquely defined by the starting index and the ending index. Okay, so if we fix one of them, and or like we just need to find the other index in that case. Okay, so here we are fixing the beginning index, that we will calculate that how many substrings are there which starts from I and is dominant. Okay, so for example, like let's say if I is 1, so we will take the indexes 4 and 6. So basically the indexes which has 0 and greater than I, or which is 1 in this case. Okay, clear?
Nish, can you please
Yes.
repeat again this part?
Which part?
That I thing, like
So I am telling that we will iterate over every index in the string. Okay, so I will range from 0 to n. Okay,
okay,
so for example, let's take I as 1 here. Okay, so in every iteration of I, we will consider the indexes of 0 which are greater than I. Okay, so for example, index 4 and 6 are greater than 1, right? And this array contains the indexes of 0. Okay, so this one, this index and this index. Okay, so
okay,
listen, listen here very carefully. While iterating in this loop, that is inside the ith for loop, we will maintain two things: the current number of ones, so the count of ones, so let's say count, or let's say c1. Okay, and count of 0, which is c0. Okay, so we will maintain these two things while going through all the substrings or sub arrays, sorry, substrings. Okay, so tell me, if I consider the substring from 1 to 4, how many zeros will be there?
1.
1. So if I know the number of zeros, can I calculate the number of ones?
Yes.
Number of ones will be 4 minus 1 plus 1, basically the length of the substring minus the number of zeros. Okay, right? So the length of the substring is 4 minus 1 plus 1, which is 4. Okay, so length of the substring minus number of zeros will be the number of ones. So we have 3 ones and 1 0, right? Now let's take the second index 6. Okay, so if I consider the next substring from 1 to 6, how many zeros we will have? Hello?
2,
2. Number of ones is
6 minus 2.
Number of ones is, come on. Number of ones is 4. So the length of the substring is 6 and there are 2 zeros among that. So there are 4 ones. Okay. So every time we move to the next index in this array, our number of zeros gets incremented by 1. And if we know the number of zeros in the substring, okay, we will also know the number of ones in the substring. Okay, till here it's clear or not?
Yes.
Yeah, it's clear.
Okay. Now the most difficult part here. Okay. So before that, let's understand one thing. Okay. So let's say I have a substring, okay, which ends at 0, and then there are like some ones after that. Okay. Okay, so this is my whole substring. Okay. So I am telling that before this 0 or till this 0, I have A zeros and I have B ones. Okay. And if I also add, and if I add these ones as well, I will have total of C ones. Okay. So to repeat again, so the substring till here or till the 0 has A zeros and B ones. Okay. And if I consider the whole substring, it will again have A zeros because you don't have zeros after this, and it has C ones in total. Okay. Clear till here?
Yes, sir.
Yes.
So now tell me one thing, or take out pen and paper and try to uh, understand. I am also telling that the substring till this 0, okay, has X dominant substrings. Okay, it has X dominant substrings. So how many dominant substrings will the whole subarray or the whole substring will have? Can you calculate this using A, B and C? If you can solve this, the whole problem is now solved. So have you got this question, what I'm trying to ask you? Hello.
Yeah, got it, but just repeat it once for clarity.
So
Yes.
let's say I have a substring which may have, like, let's say 1, 1, 0, 1, anything it can have. Okay. So I'm telling that till this index, the substring has A zeros, B ones, and the number of dominating substrings till this index or till this or 0, that is the last 0, is X. Okay. So it has A zeros, B ones, and X dominant substrings. Okay. Now let's say if I add a few more ones after this substring, or if I append few more ones at the end of this substring, so it will have C ones, A zeros. Okay, because the number of zeros is not increasing, so the number of zeros will remain at A. Okay. So how will X change, or how many dominant substrings will be added for the whole substring?
For each x, there will be C minus B, no? Like for all the substrings in X,
Hmm?
the number of substrings that will be added will be C minus B into X.
It will not be into X, it's a substring, so it's not subsequence, it's substring. Okay. So if you, let's say if you want to take 2 ones, you have to take it at once.
Okay, okay.
So you can't do it like this, that I have a substring, I will add like this one, then this one. If you want to take the 3 ones, you have to take it at once. If you want to take 2 ones, you have to take the first 2. If you want to take 4 ones, you have to take the first 4.
Okay, okay.
So you're going in the right
Unless it may
direction.
be X,
Yeah, go ahead.
yeah. It may be X plus C minus B multiplied into X.
Why multiplication, I am not understanding.
each one will dominating x substring.
So let's say if you want, it's not about each one. If you want to select this one, you have to select the first two as well, right?
Yes,
Yeah,
correct.
these will be just extra ones. So the third will be considered one only, not three.
Yeah, so that if you
Yeah.
want to take the third one, you will have only one substring, not three substrings. Okay. So
Got it, got it.
so let's say if there are x dominant substrings. So let's say if there are x dominant substrings, so you can add the first one with it. So the number of dominant substrings is added by 1. Okay. Then you can add this substring. It gets added by another one. So the number of dominant substrings is increased by these many ones. Okay. So what is the value of these many ones? It's c minus b. So it will be x plus c minus b. Simple thing. So what you can do here is that, so let's say there are x dominant substrings. So this is the first dominant substring. Okay, so let's say the dominant substring is d1. Then there is another dominant substring called d2. Then there is another dominant substring called d3. Okay. So what are the options that you have for these dominant substrings? Okay. And remember one thing, why you are thinking it should be multiplied here is that only one dominant substring can end with this index. Okay, since it's a substring. So there will be exactly one dominant substring that can be extended with these ones. Okay, that is ending with 0.
Got it, got it.
So it will be x plus c minus b in one case. Okay, there can be another corner case. Think about it. So let's say if the number of substrings, if x is 0, okay, there is no dominant substrings, and a is greater than, or a is much more larger than b. So what will happen? So
Hi,
there,
Anish. Hello.
hello.
Yeah, this part is actually it's a bit confusing. This part, the sub array, the substring you are saying, that will have x number of
Yes,
dominant substance, right?
yes.
Okay, so after that, I'm not getting the c minus b part exactly.
So let's say if there is a substring ending at this 0, okay.
Okay,
So I can extend that dominant substring by adding ones at the end.
right, right.
So how many options do I have? I can add a single one and still make it dominant. I can add two ones and still make it dominant. I can add three ones and still make it dominant, because adding one to dominant substrings keep it as one. Okay. So a dominant substring, if I append ones at the end of a dominant substring, it will remain as dominant. Okay. Because the number of ones is increasing, but the number of zeros are same. So it will remain as dominant. Did you get this part?
The because you're saying ki there is a zero, so that zero will be in, but like only one dominant
Simple
string.
thing. I am telling that there are some dominant substrings. Okay. So at the end of a dominant substring, I am adding one. Okay. So let's say if I add one to a dominant substring, or at the end of a dominant substring, it will remain as dominant, right? Because I am
Yeah,
increasing the number of ones, so it will remain as dominant. Okay. So I will have 5 options or 5 choices with the dominant string. Okay, so the number of dominant strings will go up by c minus b. C minus b is basically the number of ones which I have at the end. Okay, so I can choose to add a single one, I can choose to add two ones, or I can choose to add three ones, or I can choose to add four or five ones. Okay, so now I have, instead of a single dominant substring which was d, I can have dominant substrings like d plus 1, or d plus 1 plus 1, or d plus 1 plus 1. So there are five
Unless
substrings like
that
this
means all the strings are starting from zero.
ending at 0, ending at
No,
this
no, I'm saying
index.
like all the strings are from past, like means in the zeroth index.
Not necessarily. I have told that till this index, the substrings can start from any index.
Okay.
The substrings can start from any index and end at any index. Okay, but you
Yeah.
can only extend the substrings which are ending at this 0 and are dominant.
Anish, can you like take a small example, like let's say 110,
So let's
then let's,
take this example only. So let's
yeah.
say 1 1 0 1 0. Okay, let's say no, this example will be perfect. Okay, so for this situation, how many, what will be a, b and c? Quickly tell me. A will be,
Uh, A is number of zero, right?
yeah,
One, right?
It is one,
b,
three,
Three,
three.
c is
five.
Mm, eight. Eight.
Oh, sorry,
8,
sorry.
8. Okay,
Eight.
so now tell me what will be x.
X will be like now X is one.
Okay,
No, no,
x is not 1.
not one. Yeah.
X is 1 2 3. I have taken a too big example, but anyway, x will be 3 4.
Anish, can you take a smaller one? Like,
Let's take out this one. Okay,
yeah.
so this will be 2, this will be 7. Okay, so the number of dominant substrings till this 0 will be 1 1 0, 1 0, so 2, right? No, 1 1 0,
Three.
1 1 1 3,
One.
1 0 1 5. Okay, so there will be 5 dominant substrings. Okay, so let's write the substrings: 1 1 0, 1 1 1. Then if I start from the second one, it will have 1 0 and it will have 1. Okay, correct.
So 10 dominant तो नहीं होगी.
1 0 dominant है ना. 1 का square is 1, equal to, greater than or equal to.
Okay sir.
ठीक है. अब मैं
Yeah,
बोल रहा
correct.
हूँ, अब मैं पहले क्या बोला, दैट आई विल फिक्स द स्टार्टिंग पोजिशन. ओके, so let's say I am taking the substrings which have started from the first index, so I will consider only these 3. Okay, correct. So now tell me how many substrings are ending at the last 0. Only one.
Right.
So I have the option to add these ones at the end of these dominant strings or this dominant string. So I can make this dominant string as 1 1 0 1 or 1 1 0 1 1, or I can keep on adding ones. Okay, so I will increase my dominant strings by a measure of 5. Okay, for every starting index. Clear? So clear or not?
Yeah, clear.
Somebody has written something, I guess. Okay, clear. So that's what I am telling, that x will be increased by c minus b, which is 5. 7 minus 2. Okay, now there can be one more case. Okay, so let's say I have one.
Anish.
Yeah,
Hello. Yeah, this part is like 110, the starting index. If it is zero, obviously like one. I mean the zeroth index. So it is 110. Then after that we are adding like extra 5, right?
yeah.
So okay, and For the second index, like 10, the
Yeah,
string will
second.
start.
So second index we will add again, right? So initially I told that I will be doing it for every I or for every index, right? So I am now only considering only one index, like only one iteration
Okay.
of I.
Okay,
So
understood.
so for every iteration of I we will calculate separately, okay? So at every iteration I told in the beginning that we are fixing the starting index, okay? So understood till here, everything is clear.
Yeah, got
So
it.
there is
Yeah.
one more condition, it will not be c minus b every time. Think about it. There is one more corner case. It can be either c minus b or it can be c minus a square, okay? And this will happen when there are no dominant strings initially. So if I take this example 1 1 0 0, okay, so let's take this example 1 1 0 0 and then there are 5 ones, okay? So and I is 1 here. Basically we are starting from the second index, okay? So what will be the dominant strings or what will be the substrings generally? It will be 1 0 1 and 1 0 0. So the first one is not dominant, okay? This is not dominant, okay? So if I want to add ones at the end of this substring and make it dominant, how can I do that? So how many, at least how many ones would I need to add to make it dominant? At least 3, right? Hello.
Yes.
So I
Yes.
so I can't add a single or a double one and say it's dominant, okay? So when a square is actually greater than b, so I have to say that I will at least have to add 3 ones, okay? So the number of choices I have is at least add 3 ones, 4 ones or 5 ones, okay? So it will be c minus a square, okay? So this is basically the algorithm. So let me go to the code once, okay? So I am
Anish,
bas-
can you repeat the last one, like the C minus A square ones?
so basically when the number of zero, when the string is not actually dominant, okay, when the string is not actually dominant, you have to add, you can't add like you don't have all the options, okay? Like for example in this situation you can't say that I can add a single one or I can't add 2 ones and say it's dominant, right? So you would need to at least add 3 ones, right?
Yeah, correct. Yeah, correct.
So how many options do you have? So you have total of 3, you have a total of c ones, right? Out of which you need to at least have a square ones, right? You can't say that I will add less than a square ones, okay? So the options left for you is c minus a square.
Oh, okay. Means the other thing like C minus A square, all the remaining
Yes,
ones
yeah.
will be converted to would be dominating.
Yes,
Right?
exactly.
Yeah, got it.
So that's basically the algorithm. And one more optimization here is that if the number of zeros is greater than root 10, we'll simply break out of the loop, because I already told that when the number of zeros is greater than root 10, you can't have a dominating string. So when the count of a is greater than root 10, we simply break out from the loop, okay? So this is the basic implementation, that I am calculating the number of ones, okay? I am also calculating the number of zeros and the number of ones in the previous thing. And this is the thing I explained here, that with A, B and C, how you calculate the dominating strings. Okay. So once you have understood this, the implementation is fairly simple. Okay. Just go back, see the recording once more and implement it yourself, you will understand it. And this was a very hard problem. I don't know why did they called it as medium. Like if you see, the acceptance rate is just 8%, even less than the fourth one, okay? So clear everyone, the third one, the logic and the implementation?
Yeah.
Okay, let's go to the fourth one. Fourth one is very simple. They tell you that they have a rectangular space. Okay, they have a rectangular space and there are some circles inside it. Okay, you just have to find a way from this point to this point such that this path doesn't intersect or fall in between any circle. So the path can't fall between any circle, so this can't happen. Okay, you just have to tell whether there is a path or not. Okay, clear? Question is clear, right?
Yeah. Yes.
Now this is a very simple question. Okay, so there can be 4 cases where the path is not possible. Okay, so one example is that the top, so there are basically intersecting circles which cover the top edge and the right edge. So for example, in this case you don't have a path. Okay, second case is that the top edge, there is two or more than two intersecting circles which cover or touch the top edge and the bottom edge. Okay, this is one more case where you don't have a path. Can anyone guess the other cases? This is one more, the left and the right. And the fourth one is that the bottom and the left. Okay, so if there are intersecting circles or circles which touch each other and touches these combination, that is top and right, top and bottom, left and right, left and bottom, okay, the answer is no. In all other cases the answer is yes.
Sir, if a single circle touches adjacent side
हो
of
जाएगा.
two,
So basically intersecting or single, like it can be also like this. So this case can also be this one. The by intersecting circles I mean a single circle or intersecting circle. Okay, so these both represent the same case. Okay, clear?
yes.
Yep. Yes, Anish. Yes.
So how do you now solve this? This is a graph problem, very easy. So there will be n plus 4 edges. Okay, so sorry, n plus 4 nodes. Okay, so every circle will be a node. Okay, and the 4 edges will be a node. Okay, so if a circle touches a edge, there will be a edge between those two nodes. Or if a circle touches or intersects with a circle, between those two nodes there will be a edge. Okay, so like this you form a graph. Clear?
Anish, can you please repeat again the node part? Node part.
So every circle will represent a node. Okay, and every edge will also represent a node. So there will be n plus 4 nodes. Clear? Hello?
Yes. Clear.
How is it n plus 4? Can you again just repeat? I just
চারটে edge আছে, like there are 4 edges and n circles.
okay, got it.
Okay, now how we will make the edges? So if the edges, so if there is a contact or if there is a touch, there will be edges. So if a edge or if a circle touches a edge, there will be connection between them. If two circles intersect between them, there will be edges between them. Or if any circle touches each other, there will also be a connection or an edge between them. Okay, clear? Hello?
Yes. Yeah.
So now the thing is very simple. You just check that whether there is a path from top to left. Okay, or there is a path from top to bottom, like the top edge top node or the bottom node, if there is a path from the left node to the right node, or if there is a path from the left node to the bottom node. Okay, if any of the paths exist, the answer is no, otherwise the answer is yes. Simple DFS will do. Simple DFS or BFS, anything. Clear? Hello.
But how
Yeah.
the top edge, like how are you going to like
So let's take this
edges?
example. Let's take this example. You will understand. So in this case, so if I take exact this example, okay, so there will be 4 edges, sorry, 6 edges, right? The top, edge, the bottom edge, the right edge, the left edge, right? And there will be 2 more nodes, the top circle and the bottom circle, right? So these circle and this edge is connected, these two circles are connected because they are intersecting, and the bottom circle and the bottom edge will be connected. Okay, so what combinations I told? Top and right. So from top, from this node to this node, is there any path? No. Okay, from top to bottom, is there any path? Yes, this is the top edge, this is the bottom edge. So there is a path from the top edge to the bottom edge through these circles. So the path is blocked, you can't go through this vertical barrier. Okay, this will not be allowed. So this path exists, so the answer will be no. Similarly, you check for the other two combinations, that is from right to left or left to bottom. Clear? Hello.
Got
So this is a classic graph problem. The only catch here is that making the graph. If you know how to make the graph in this problem, the rest of the things are very easy. So the graph is basically having n plus 4 nodes and the edges as I described. If there are connection between the entities, there will be an edge. And then you have to check for these 4 paths. If they exist, the answer is no, otherwise the answer is yes. Cool.
so Anish, like so how we are going to do is basically we'll be representing every like every circle as a node, okay? And after that we'll be taking the 4 edges as nodes.
Yes.
Now for each circle we'll be checking like all the 4 edges, whether that particular circle is connected to it or not, right?
Yes. We will also check that whether the circle is touching or intersecting any other circle or not. If yes, there will be an edge between that circle, those two circles as well. Okay. So
Okay.
if there is any connection between the circles, there will be an edge. For example, in these two circles, there was an intersection, so I connected these two circles. Okay. So the nodes part is clear, right? What will be the nodes? Hello.
Yes.
And the edges part?
Yes. Yes.
Great. Cool then. I think just absorb the questions which you couldn't solve during the contest. And that's all, I think, for this discussion.